So now we will commence on some of the more geometric properties of circles that you're going to have to use when you're solving problems with circles and lines to supplement the algebra. And so there are three main ones that you need to really remember. The first is a tangent is perpendicular to the radius at that point. So what it looks like is this point we have a radius, drop it down there. It's a bit more than a radius, but whatever, it will make my point. And see this bit, that's a tangent, touches at that same point, and you got a right angle there. And this allows for stuff like SOHCAHTOA, because you can form right-angled triangles and stuff like that, and Pythagoras as well. For example, say you had a bit of a question, how something along the lines of this, and something like that. Given enough information, you could prove that this would be forming a square by using that property of those ones here, and then just proving that with Pythagoras that these are the same length, something like that. So that's the first one you need to remember. The second one is angle in a semicircle is 90 degrees. So if I drew something like this, and I drew a diameter, turning it into a semicircle, no matter what I do, this is going to be 90 degrees. And so, if you can prove that two chords are perpendicular to each other, you would prove that this here would be a diameter. And the last one would be that it's a bit related to this, but the perpendicular bisector of a chord goes through the centre. So if we take a chord like that, and then we bisect it, this is the midpoint, and we go perpendicular, like this. Then, if I line that up properly, like more like that midpoint, it would pass through the centre at some point. And then if we did another one, then we would actually locate the centre. Something like that. So the perpendicular bisector of a chord passes through centre. And this is probably an important reminder to remind you that you are obviously expected to know all your angle rules from IG. So things like this, if you say that that's the thing at the centre, this will be like that. If that's A, then that'll be double. The butterfly wings, these are equal. And then cyclic quadrilaterals. Like this, and then if we do this, A and B, A plus B equals 180. And then I'll just turn it segment theorem. I believe it was this angle is equal to that one. Yeah. So you are expected to remember that stuff. I don't think you'd ever have to use it, but you are expected to remember that stuff. And obviously you'll obviously need to know things with straight lines, or the other angle rules with straight lines and polygons for circular measure as well. So now we'll move more on to the algebra side. So intersections with a line. Obviously, say if it's y equals 2x plus 1 and some circle, you know how it's like x minus something squared plus y minus something squared equals the radius, I don't know, like 25. What you'd do is you'd substitute and then you'd solve for x, then you would solve for y with the two solutions that you got. Or it may only be one solution. So, for example, that's how you do it. It's simultaneous equations. I don't think I need to go through that. I'll just tell you that's how you do it. Now, one thing that you may need to do is, now this will come back to the discriminant, showing number of solutions. So you can show there are two intersections. Show that there is one, i.e. the line is tangent. Show that there are no. And this comes back to the discriminant, back up to the quadratics topic. So, for example, if we have a look here, y equals x minus 13, and x squared plus y squared minus 8x plus 6y plus 7 equals 0. And we want to see if that's going to be, if what line L, is tangent. So we'd substitute the y in where we have we'd substitute the y for x minus 13. And this is x squared plus x squared minus 26x plus 169 minus 8x plus 6x minus 78 plus 7 equals 0. That's 2x squared. We subtract 2x minus 28x. Okay, one's equals 0. And then if we were to do a discriminant, we'd do this. We might as well divide it, just to make it a bit easier. I mean, we could very easily just go like that, and we can see that there's a repeated root, so it will be tangent, but for the argument's sake of the discriminant, that's 196, and 4 times 49 is 196, I think, and it's 0, which means it's only one intersection. But another question type that should for sure know how to do is find set of values of m for which y equals mx plus 1 intersects x minus 7 squared plus y minus 5 squared equals 20 at 2 points. And so essentially we will do the same substitution and then we'll go ahead and we'll expand first. M squared x squared. And that 1 minus 5 is minus 4. So that's minus 8mx plus 16 equals 20. So then that's m squared plus 1. We'll bracket that off, the x squared, minus 8m plus 14 x. And that gives us 65, so 45. Like that. And now we apply discriminant. And we go, the discriminant is equal to b squared minus 4 times a times c. So if we expand this out, we get 64m squared plus 224m plus 196 minus 180m squared plus 1, so that's m squared plus 224m plus 16. Oh, hang on, sorry. Plus 196 minus 180m squared minus 180. So that gets us minus 116m squared plus 224m plus 16. And that, if we divide all that by something, we would get, so that would be, if we divide that by 4, we get 25, that's minus 29m squared plus 56m plus 4. And now we want to figure out when this is greater than 0. And now let's try and factorise this. So AC equals, what is it? 4 times 29 is 116. Oh, yeah, we've already done this, so that'll be 116. The brain's going. And so let's try and factorise this. Let's have a think. 116, what can we divide by that? Honestly, at this point, I honestly would have already gone for the quadratic formula. But it's right in front of you, 58 and 2, I think. M squared plus 58m minus 2m plus 4. We're trying to go greater than 0. 29m. So that leaves us m in the bracket minus 2, then minus 2, m minus 2 would go here. And so that would pull out bracket 29 m plus 2, m minus 2. And that needs to be greater than 0. So what we've actually got here is, because we got that negative sign, we've got an n-shaped parabola. So in order to be greater than 0, we're actually going to do this part. So it will be the x values between the critical points. So we say critical points at m equals minus 2 over 29 and m equals 2. And so we say that for it to have two intersections, minus 2 over 29 is strictly less than m, which is strictly less than 2. Now, obviously, if it asks for the 2 points where, 2 values of m where it will be tangent, you would say m equals minus 2 over 29 or m equals 2. For tangent, I'll note. And if it asks for where there are no solutions, you'd go m greater than 2 and m less than negative 2 over 29 for that. there are some challenging problem-solving ones out there, and you do just need to keep chipping away at it. And the most important thing, I think, is these geometric properties, use them creatively. And might I remind you that a circle is very symmetrical? Use those creatively, and they can be very much used to be solved. They can very much be used to solve the hardest of circle problems. Perhaps and the closest distance, by the way, between two circles would be whatever this distance is, d minus r1 minus r2, and the greatest distance would be d plus r1 plus r2. That seems obvious, but maybe it isn't. In addition, on a final note, I highly doubt you'd have to do this, but finding the points where circles touch. What I would do is I would do an elimination. And then from doing that, so for example, if I took the example of x squared plus y squared equals 25 and x squared plus y squared minus 24x minus 18y plus 125 equals 0, what I could do is I could replace that with that and say this. Something like that. And then if I shifted some stuff over to the other side, so this is 150 clearly, and we got 24x plus 18y. And then if we did some division, and we simplified it a bit, we would get this. And essentially what I would then do is the points of intersection are going to lie on this line. So I'd rearrange this into get either x or y as the subject, and then I'd put it back into, say, this one, and then it will give me either the x or the y coordinates depending on which one you choose to do first. Then you can resub back it in for the other one. And if it's a repeated solution for one of them, that would prove that it's tangent as well. So, yes, that's all I have for this one. Circles can be quite difficult, but sometimes you do got to get creative. Similar triangles may also help. Similar triangles helps a lot of the time. But just definitely think about those ones.